So moving on to 6.5 Fibonacci type sequences and recurrence relations. Our learning intention, what is Fibonacci sequence and how to find an unknown term from the sequence. Success criteria, I can define the Fibonacci sequence, I can create an equation and find unknown term using the equation. Alright, so first of all, Fibonacci, or just a random word to use. Why call it Fibonacci sequence? Fibonacci sequence was named after the guy that figured it out, Fibonacci. He was a mathematician from about the 1200s, an Italian guy, and is often referred to as the greatest Western mathematician. In my opinion, he's pretty awesome. So from a real world application, we can utilise this Fibonacci sequence. When he was looking into it, he was looking at a rabbit population. Then he went from a rabbit population to sort of the family tree of a bee, honeybees. You know, you've got your queen bee, all the males, and the females. The females have no, like they didn't reproduce, but the queen bee reproduced constantly. So effectively, like bees are incestuous. Not going to worry about it, but it is all, it all is part of the Fibonacci sequence. So the other place that, or the other real world application or the real life nature that we find Fibonacci or the Fibonacci numbers occur is within the shapes of shells. So if you're looking at page 283 of your textbook at any point in time, you can see this pretty awesome shell. I will show you when we get back to reality how this shell works. Until then, we'll just go on with the maths of it all for now. So, the Fibonacci sequence and second order recurrence relations. The following is called the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, 21. After the first two terms, each term is the sum of the two terms before it. So, alright, first of all we need to find our T1. Let me find a pen that's going to work on this screen. Alright, our T1, our first term is 1. Our term 2, in this case, is also 1. Now, in order to get to our term 3, we add the two terms before it. 1 plus 1 gives you 2. Then, our term 4, we want to add the two terms before it, which is term 2 plus term 3. And 1 plus 2 gives us 3. Term 5, we add the two numbers before it, so term 3 plus term 4, 2 plus 3 gives us 5, and so on and so forth. If I wanted to find the 95th, so term 95, I need to have the 93rd plus the 94th. Only issue with finding the 95th term is that you need to find the 94th, the 93rd, the 92nd, the 91st, the 90th, all the way down to and know the first and second terms. So from this, we can actually create a formula or devise a formula. Using this particular pattern, we put T1 is equal to, in this case, it's 1. And T2 is equal to 1. Our formula, which we can use any formula, and the only things that change are our T1 and T2 values, is T of n, so whichever number we want, is equal to T of n take 2, so the two numbers before it, plus T of n take 1, so the one number before it. As I said, if you wanted 95, down here in 95, you have 2 less than 95 is 93, 1 less than 95 is 94. It sounds like a lot, sounds confusing, but when we get in a couple more slides to the point of doing examples, it gets a lot easier. So this is a second order recurrence relation because it links terms that are 2 steps apart in a sequence. So from this, we need to know the 2 previous steps or the 2 previous numbers in order to find that third number. All other recurrence relations we've looked at have been first order recurrence relations that linked terms that are only 1 step apart in a sequence. So for example, with a geometric sequence, this guy here, we've got our common ratio and our initial value. We only needed to know one number difference for geometric. Then the other one we went through was our arithmetic. We needed to know our initial again and our difference, which is a constant number. When we get to our second order relations, so anytime you see on an assessment that it says second order recurrence relation, it refers to Fibonacci. We need to know 2 steps away and 1 step away to be able to find this guy here. All right, we're going to go through some examples. Find the first 6 terms of the sequence that is generated by the recurrence relations T1 equals 2 and T2 equals 3. Now, on your textbook, it is on page 284, if you're following along with that. All right, T1, 2. T2 is equal to 3. Remembering, I'm going to colour code everything here. 3, 4, 5, and 6. So for T3, I need to know these two, the 2 numbers before it. So T1 plus T2 equals 2 plus 3 gives me 5. Then in order to find T4, I need to know T2 and T3. Three plus 5 gives us 8. We'll go yellow. Might be a bit ordinary on the screen. Yeah, it'll be pretty ordinary. Let's go orange. So T5 is equal to T3 plus T4, which is 5 plus 8 equals 13. And our last one, purple. T6 is T4 plus T5, which is equal to these guys here. 8 plus 13 gives us 21. So our sequence would end up looking like 2, 3, 5, 8, 13, and 21. As you can see, we're just adding up the previous 2 terms to make that next term. So moving on to part B. Write the recurrence relation for -3, -2, -5, -7, -12, -19. You look and think, oh my gosh, this is getting pretty tricky. But it's not really. You need to just use the same formula as we used earlier, which was T of 1 equals T of 2 equals T of n equals T of n take 2 plus T of n take 1. The only thing that we need to fill in this case is our T1 and T2 value. So that's the only way it differs formula-wise from every other Fibonacci is just -3, -2, these 2 numbers. This formula doesn't change. So when you're making notes in your books, put this formula in. All right. C. For the Fibonacci type sequence that has T8 and T9 equaling 68 and 110 respectively, find T6 plus T7, T10 and T11. All right, let's start with T6 plus T7. Bit of a trick question. If you know that the 2 preceding terms equals the next term, you know that term 6 plus term 7 gives you term 8, which we already know up here to be 68. So that's part 1 done. Part 2, T10. But in order to find T10, I need the previous 2 numbers. T8 plus T9, we've got both of those, which is 68 plus 110 equals 178. The third part, we have T11. Remembering we need the two previous numbers. Two numbers below 11 are T9 plus T10 gives me T11, which is 110 plus 178 equals 288. Looks about right. Okay, last slide. For the Fibonacci, this is actually from your textbook, Prep 3, using the same concept or the same example as the previous one. For the Fibonacci type sequence that has T7 equaling 57 and T8 equaling 92, find T5 plus T6. So we remember T5 plus T6, the two previous numbers, equals the one after it, T7, which we already know, 57. T9, we've got to remember, the two numbers before it are 7 and 8, so we've got T7 plus T8 equals 57 plus 92 equals 149. Let me just double check. Yes, I use a calculator. 57 plus 92, 149. Awesome. And then I'm going to move C down to here. There's not much room. T10. So for T10, I need the two numbers before it, which are T8 plus T9, which is 92 plus 149 equals 231, 241. Let me just double check again. 92 plus 149, 241. Cool. So that is it for 6.5 Fibonacci.